We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did. But that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They are free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 6/10% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find a solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 and 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can't physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they are made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has two of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These two space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades, but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the fourth planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. It's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years, and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you.
You wake up in your ultra-modern dwelling, go out on the balcony, and admire the incredible sandstorm in the distance. The reddish wall is approaching and has already reached the parking lot where your shiny Starship rocket stands. When the storm subsides, you put on your spacesuit, get in your rover, and drive to work. Your job today is to monitor the instruments in the freshwater extraction plant. In the evening, your shift ends and you return home. The cooking robot has already prepared dinner, fried potatoes, grown right here on Mars. This scenario could be true as early as 2050 and even sooner. Elon Musk plans to send 1 million people to Mars by then. Very ambitious, but incredibly difficult to accomplish. Flying to Mars is very expensive and time-consuming, and it consists of several stages. We're heading to the launch pad, where the first Starship is being prepared for takeoff. The rocket consists of 2 parts. The first is the Super Heavy booster. It'll help the heavy craft overcome the Earth's gravity and leave our planet. It should take Starship into orbit, then undock and land back on Earth. At that time, Starship has to hover in orbit, having used up almost all of its fuel during takeoff. The next step is to refuel Starship right in orbit. The booster takes off again from the launch pad and carries fuel for the main spacecraft. Starship is still empty because we don't want to spend a lot of fuel to lift it out of orbit. So now, it's time for another booster rocket to carry a payload for Starship. Food, construction materials, and research equipment are stacked in the cargo bay. All set at last, our spaceship sets off on its long journey towards Mars. This is how just one ship is planned to be launched, but it can only hold 100 people, while we're planning to send 1 million there. That's almost half the population of Brooklyn. That means we'll need at least 10,000 ships for the whole mission, and even more booster rockets to refuel and send cargo into orbit. Considering that one Starship costs about $8 billion, this mission would cost a pretty penny. The key to solving this problem is reusing these ships. Once the ship has delivered people to Mars, it should be refueled and sent back to Earth for the next batch, sort of a space bus. Another problem is time. The orbits of Earth and Mars aren't perfectly circular. They're of different lengths and make circles around the Sun at different speeds. When Earth and Mars are at their farthest apart, the distance between them is about 248 million miles. And the closest distance, when the Earth is perfectly between the Sun and Mars, is 34 million miles. This is our target. Once every 26 months, Earth and Mars meet at this distance, so this is the perfect time to launch a rocket to keep the flight time as short as possible, between 6 and 8 months. If the first flight is scheduled for 2025, and we plan to complete the mission in 2050, we would only have 12 such flight windows. We would need to launch at least 833 ships in each window. Then there's weightlessness. On a trip to Mars, astronauts will spend more time in zero gravity than people now spend on the International Space Station. Without gravity, people's muscles weaken. Even the distance between their vertebrae slightly increases. So, during the missions, astronauts actually become a bit taller. Throughout the voyage, the team will have to constantly train in the gym to be ready for the hard work upon arriving on Mars. In addition to ships with people on board, cargo ships will also be needed. When people arrive on Mars, they will need to build an entire city from scratch. Construction materials, tools, machines. The massive cargo Starship can take on board is about 75 tons. That's about 30 SUVs. So, we'll need a lot more ships to get everything we need. And that doubles the cost of the whole mission. There's a cheaper way to get to Mars, though. The Gateway Station on the Moon. It's kind of like the ISS, only it orbits our natural satellite. It'll also have many modules for astronauts, living bays, storage bays, docks for ships, and research units. The whole point is that it's much easier for a spaceship to launch from such a station because there's no gravity. And then, the ship doesn't have to use an incredible amount of fuel to leave the Earth's atmosphere. It took about $100 billion to build the ISS, and building Gateway could be even more expensive. But it should save us money in the future. The small Orion spacecraft will lift astronauts from the surface to the station. Then, after preparation, the astronauts will go on a long journey to Mars. Let's go a little bit forward in time. The first few ships have delivered their load on the surface of the red planet. Beach umbrellas and deck chairs will have to wait because it's time to build the city and prepare for the arrival of the next group of people. The priority is energy. For this, we can use solar panels like on Earth or nuclear power plants. The next step is to build houses. Because of the lack of atmosphere on Mars, nothing will protect us from the sun's radiation. So a great option is to build houses underground. Now we need to take care of water extraction. There are ice caps at the poles of Mars. We can take water from there. Then, oxygen. Plants have to help us do that. There's a lot of carbon dioxide in the air of Mars, which serves as a kind of food for green plants. And as a waste product, they release oxygen. All we have to do is collect this oxygen and use it to breathe. Sooner or later, the food we bring with us will run out. So, we'll have to grow food directly on Mars. This requires fertilizers and greenhouses. Now that everything else is taken care of, the main task is to produce fuel. We need it for vehicles on Mars and for rockets to be able to return home. Fuel can be extracted from the carbon dioxide in the atmosphere and water. All this has to be done in completely unfamiliar conditions. Gravity on Mars is 3 times weaker than at home. You'll be able to jump higher and lift heavier objects, but prolonged exposure to such weak gravity can harm our bodies. Now that there's a whole city on the planet's surface, it's time to turn Mars into something more comfortable, resembling Earth. This is called terraforming. We need to increase the pressure in the atmosphere so that water can exist here not only as a vapor or ice, but also in liquid form. We also need to raise the temperature of the surface. Our goal is about 68 degrees Fahrenheit. Right now, it's about -81 degrees Fahrenheit on average there. Then, we need an ozone layer, like on Earth. It should protect us from solar radiation. Finally, we can start creating the biosphere. That's all living organisms, plants, and animals. Gradually, Mars will start to resemble Earth in its best years. For all this, scientists have come up with many solutions. For example, a large asteroid could be dropped on the surface of Mars. This would warm up the atmosphere and bring more water and gas there. The planet could also be populated with different bacteria. In laboratories on Earth, scientists have simulated conditions on the surface of Mars and realized many bacteria can survive there. As long as they live, they can release oxygen and other gases into the air. Besides that, we can build biodomes. This is a kind of greenhouse with favorable conditions. Life will develop in it, and the soil of Mars will gradually become suitable for life. And one of the easiest ways is the greenhouse effect. On Earth, it contributes to global warming, but on Mars, gas emissions from cars and factories can help create an atmosphere. Optimistically, it could take 300 to 1,000 years to change the face of the red planet. Other scientists say it could take millions of years. Only then will humans finally be able to take off their spacesuits and oxygen masks and call Mars home.